Thank you, Sandy. Morning, everyone. It's great to be back in a room full of people and not have to use a pause button on Zoom or Teams. Can I begin by just acknowledging the traditional owners of the land we meet, the Gadigal people of the Eora Nation, and I pay my respects to their elders past, present and emerging. Now, Indigenous Australians were our first manufacturers, inventors and innovators. You only need to look at the Woomera, the boomerang, thermodynamic plastics, resins. They're just some of the remarkable examples of this manufacturing talent. So I'm excited to be here today. I've got a great passion for manufacturing and technology. And I'm keen to discuss the role of advanced manufacturing in the aerospace industry. And I look forward to hearing from other speakers today who have great experience in research and industrial applications for advanced manufacturing. But before starting off, I really wanted to just acknowledge the work of the Western Parkland City Authority team, not only for bringing us all here together, but really doing the transformational work to actually set the kind of bedrock foundations for the growth of the industry and the growth for all of us in this room. So thank you. And also acknowledge the work and the funding commitment, $260 million investment by the New South Wales Government, the advocacy of Minister Ayres. Like these are no small contributions, and we really need to acknowledge them. And I actually think they lay a foundation for a bit of a renaissance here in terms of additive manufacturing. So before I begin, I just wanted to set the scene and tell you a little bit about GE's journey towards advanced manufacturing and in particular additive manufacturing. I'm going to use AM as the shorthand, and the role we're playing in supporting Australian industry. So GE is a company that's been represented in Australia for more than 125 years. And our contribution to Australia has evolved over that time in very different ways, but it's always been characterised by the deployment of new technology, leading edge technology and the transfer of specialist skills that enables our customers to thrive. There's a good chance today that if you flew in to this conference on a plane in Australia, there was a GE jet engine that was actually built using additive manufacturing technology. The power that's actually lighting this room today might have come from a GE wind turbine that's transmitted through GE grid infrastructure on a network that is largely controlled by GE digital network software. And if you or your family need medical assistance, which I hope they don't, you can find GE ventilators, MRI machines, CT scanners in almost every hospital and clinic around Australia. So we've got a history of developing and deploying technology and working to establish long-term partnerships to deliver on our mission, which is to build a world that works, helping our customers achieve greater efficiency and sustainability and invent the future of flight, driving innovation in precision health to address critical patient and clinical challenge, and of course, supporting customers and communities seeking to provide affordable, reliable and sustainable power, something that's very, very close to all of us at the moment. So let's get to the substance of what I wanted to speak about. Advanced manufacturing, or 3D printing, is an industrial process that creates three-dimensional objects by depositing materials such as powdered metal alloys or plastics. Using computer-aided designs or 3D scanners, additive manufacturing allows for the creation of objects with far more geometric freedom than traditional subtractive manufacturing processes, and thus enables novel approaches to component design. In essence, you can build things using AM that other manufacturing methods don't permit. Using metal alloys, metal powders, AM allows for objects that exhibit certain characteristics, and this is really crucial for the AM story. Characteristics around strength, heat and pressure resistance, durability or aerodynamic qualities. As we'll see, AM also allows businesses to minimise assembly costs, taking dozens of individual parts and printing them as a single item, thereby reducing cost and inventory. And that business model around additive is a really important proposition to the story. I'm often amazed how technology is changing business models by enabling faster production development times, improving internal rates of return on investment and reducing costs. AM is really a disruptive technology and allowing manufacturers to compete in a world where knowledge is increasingly becoming the dominant global currency. So let's look quickly at GE Additive and what we provide. Machines, and I'll talk about a little bit about the different types of machines, electron beams and laser machines and binder jet machines, powders and alloys, titanium, aluminium, cobalt, chrome, nickel, other alloys that our research community are probably making as we speak in our great universities. AdWorks, and I want to touch on AdWorks very briefly, which is a team of engineers that basically help our customers understand additive and understand how to apply it. And then, of course, software. And we're not only talking about the CAD software, but the software embedded in machines. And GE Additive has launched its own APM software platform recently. So let's look very quickly at the different types of technologies. And these technologies are continuing to evolve. Direct metal laser machines that can melt layers of fine metal powder and create complex geometries with incredible precision directly from a CAD file. And then the electron beam machines create dimensionally accurate parts quickly and efficiently using a high-powered electron beam. The process takes place in a vacuum at elevated temperatures, resulting in stress-relieved components with material properties better than casting material. And finally, binder jet, which is, I suppose, the latest of the technologies that allows for repeatable and reliable printing of not only small but very large parts comparatively, and printing speeds of 100 times faster than other AM methods. So there's this kind of evolution in technology, and different technologies suit different applications and different outcomes. AdWorks. I really wanted to briefly touch on this because the journey to additive manufacturing is a journey about technology, but it's so much more than that. It's about understanding the depth of experience, the design, materials and processing that you need to understand to actually apply the technology. You know, an AdWorks assessment, for example, can determine if a part is appropriate for additive or better produced conventionally. You could print a tablespoon with additive, but is that the most efficient process? No, unless you need that spoon to go to space or have an aerodynamic quality or capability. AdWork also provides training, and we've been delighted to partner with the University of Western Sydney University on an AM micro-credentialing pilot program. So it's a really important part of the message. It's not just the technology. Technology is an enabler. It's what wraps around it. So this is our journey in terms of where our journey with additive started. And it didn't start too far ago. It's only a decade old in reality. It started in the acquisition of some core technology back in 2012. And that technology was originally used in our aviation business, where it became an essential ingredient to enable us to kind of develop new components and aviation engine parts, delivering cost, quality and performance benefits. And since then, you know, we've expanded in the aviation sector, and we now have a huge portfolio of customers and a global footprint, predominantly based in the US and Europe. However, we're seeing incredible interest around additive technology in the Asia Pacific region, from Singapore, Korea, Japan, and of course Australia. And I think the AMRF kind of provides this opportunity to be an anchor for the region in terms of capability. So I wanted to now just go through some examples of additive technology and applications in aerospace. Now this is actually a couple of years old, this example, but it's an example of a next generation radio frequency antenna. And basically the company Optimus focuses on using advanced design for additive manufacturing principles and reflecting these in their satellite systems. So what's interesting is that every joint, seam or fastener within a non-AM printed antenna provides the opportunity for loss of signal. So when you actually use additive manufacturing, you allow a capability to kind of what they call tolerance stack the parts. So no longer does the manufacturer at the end need to make sure those 100 parts are meeting their performance criteria. You've minimised that risk by using additive manufacturing. And of course, you can reduce the weight from kilos to grams. Very important when every kilo into space is an awful lot of money, and reduce the lead times in terms of being able to bring these new products to market. So really interesting application, and just demonstrates the strength of what the technology can provide. This is an example that GE is very proud of, and it's our fuel nozzle. And basically, we were developing a new engine, and we really wanted to be able to push the efficiency of that engine, and the fuel nozzle plays a really important part of that. And we knew we couldn't do it with traditional manufacturing methods. So, you know, particularly the internal complex designs, the airflow of what's inside that fuel nozzle is very complex. So using additive manufacturing, we allowed 20 conventional parts to be built as one. The development time was collapsed, the part's more durable, and of course it weighs less. And we see this as a really critical factor to, you know, a combustion chamber within a jet engine. What's really interesting here, and this is, I suppose, the word of caution I'd share with people. We had two contractors that were building these pre-additive. So they did a great job of building conventional applications, casting and post-finishing. And they woke up one morning knowing that GE had this capability to do it themselves. So it really is a disruptive technology, and not to be in this space, you've also got to see you might yourself be disruptive without having that capability. Fuel performance is really critical for the aviation sector, and it's the kind of panacea in terms of increased efficiency and reduced fuel consumption. And fuel nozzles and all sorts of applications in aerospace space around reducing weight. I mean, Virgin Atlantic suggests if you took 0.5 kilogram of weight off every plane in their fleet, they would save 53,000 litres of fuel a year. And if you want to look at Qantas, when they were trying to prepare for their flight from Perth to London, they looked at, you know, cutlery, crockery, glassware, because every gram actually mattered in terms of cost. I think, not to be quoted, but I think there's a figure which is, you know, every kilogram's about $1 million worth of operating cost over the life of an aircraft. So weight is a really important proposition. But I want to take you through the next part of the story, which is GE started on individual parts. Now we're talking about whole components for engines, and the place to look there is quite a new engine, the GE9X, which is a great example of extended integration of additive manufacturing in an engine. So we took a family of parts, and if we have a look at the next slide, and we said which technology, is it electro beam manufacturing, is it lasers? How do we build different components? And we ended up with an engine with 300 additive parts integrated. So that's a big step change from the original proposition, which was printing one fuel nozzle. Better durability, better efficiency, and importantly, a really simplified supply chain. What we're seeing now, though, is a further kind of development in terms of beyond, you know, using additive to develop new products or items in production. What we're seeing in Singapore is our repair, maintenance and overhaul facility for our aviation business being approved to use metal additive manufacturing for commercial jet component repairs. So this is a first globally, and it has increased, productivity has increased, with employees able to repair twice as many parts in a day compared to the conventional repair process. But there's also another proposition. You need less tooling to repair those parts. So floor space is reduced by a third. So there's these flow-on kind of economic implications associated with additive, the application of additive technology. So today, it's right through our aviation business. There isn't an engine, well, there might be, but I haven't come across one where additive manufacturing doesn't play a role. And as part of this journey, GE is really, and we heard it from the earlier speaker around standards. We've got better at understanding standards and being part of that. We've got better at being certification. And we've also developed our research capabilities and partnerships, and certainly we're really thrilled to be doing that with University of Sydney at their Sydney Manufacturing Hub. So let me briefly, I couldn't help but, given the rave reviews on the Top Gun movie, I thought I should share with everyone the backstory to Top Gun. This is the reality of the story. So beyond commercial aviation applications, we're seeing an uptick in additive manufacturing and defence, and the Pathfinder program aims to tackle the US Air Force sustainment issues around integrating metal additive manufacturing into their production flows and providing a new method of sourcing out of parts production. So here's the kind of the fact point. Between 2011 and 2019, a staggering 50% of all US military aircraft did not meet their mission readiness goals because of hard to obtain parts. In some instances, suppliers may no longer exist. So as a consequence, they went on this journey about how do they actually fill that gap, and they found additive manufacturing as a quick and simple solution. It took time, obviously, but the first part of that program was actually a sump cover, not a hugely complex proposition, but it was the first design and product metal additive to be qualified by any US Department of Defence entity. So that was a big step change in terms of how people think about parts and kind of filling that gap in terms of sustainment. And we're seeing similar situations in terms of sustainment challenges in other defence services, militaries in Europe and Asia. And so we're seeing an uptick in terms of, defence wanting to actually get into this space and understand it more. So there are a couple of examples of how we've used the technology both within our own business and how we're seeing the technology being applied in other sectors. But I wanted to leave everyone with some kind of concluding thoughts and observations. I mentioned earlier that knowledge is really a global currency, and I honestly believe that. It is the global currency for the world our kids are going to live in, for the world we're living in. And it's no longer sufficient to be a technology consumer. Technology is just an enabler, but what matters are the skills and capability to apply new technology across an economy or an industry. And what we need to do is get better at being able to take very new skills and apply them quickly across an industry or more broadly across an economy. And the question is, how do you do this? Well, it's actually a challenging task, but it requires a couple of things in my view. One is long-term investment, and I think the ARMRF kind of serves as that vision in terms of this centre is not being built for the next 4 years, it's being built for the next 20 years, and so is the Bradfield City. We need to invest in the latest technology, and I mean the latest technology. The technology, if you look at just the slides in terms of where we started on our additive journey within GE, it's just grown so quickly in those last 10 years. And we need to continue to invest in the latest technology, but invest in skills and support R&D that enables Australian manufacturers to be more than technology consumers. We need to be able to add value to new technology that is constantly evolving. So key message is adding value to technology, not just being a consumer of it. Disruption, well, we've all gone through 2 years of disruption, and in my view, it actually presents an enormous opportunity for Australia. It will allow us to accelerate the decarbonisation of our energy system, to be part of new supply chains and develop new business models. I think we need to recognise that globalisation has taken a U-turn, and I see it in GE's global business, that the days of old supply chains are being refashioned incredibly quickly, and maintaining a business as usual approach is no longer a strategy for success. If you ask people here in this room, manufacturers, about inflation, inflation is a critical issue. How do you control it? Well, there are ways you can do it, but you need to. You don't want to be exposed to it. That's for sure. Competition. Technologies such as AM can support greater competitiveness and productivity for Australian manufacturers. However, it would really be a mistake to think that our competitors in Singapore, Korea, and Japan aren't thinking similarly. We need to act with a sense of urgency and be prepared to tolerate greater business risks and governments to tolerate greater risks, embrace new technology and skills. And as we've seen over the last 2 years with our response to COVID, Australia is actually a pretty resourceful bunch of people when we're tested, but we've got to take that and continue to apply it. And finally, collaboration. Advanced manufacturing in Australia require a renewed sense of collaboration between industry, government, and those who provide skills and training, and also those who create knowledge, our world-class universities. We need each of the players on the team to be successful if we're to win the match. So we need all of those parts of the equation to be successful, not just any one individual part. So let me leave you with a vision for advanced manufacturing I'd like to see in the future, where Western Sydney is not a hub. That Western Sydney is not a hub for Australia, but it's a hub for the region, and a leader in additive manufacturing skills, training, research and development, and technology deployment. and where our manufacturers are providing high-value products and components into new global supply chains. Thanks for your attention.